Now we're finally in a position to get a roadmap to what it is we want to do. So we want to be able to write a program out in a high level language, we want to compile it into assembler, and then we want to go through the assembly pass 1 and pass 2. So if you open up the spreadsheet, which is in the resources section, it's called assembler compiler. So go ahead and open that up, and again you'll be left with something that looks like this. Okay, so if you notice that there's a sheet here that's called C simple. So what I've done is I've created in effect a little C code or something that looks like C. Okay, so let's talk our way through it. So we've got a high level program here. So we're going to have our main here, which is the start of our program, and we have our curly brackets and our closed curly brackets. So if you're used to seeing C, then this is how we would start a program off. In this instance here, we're going to dimension 3 variables, and they're going to be integers. Now we only have 1 byte variables anyway, so we don't have options to have any word or long word or any other bigger variables. So it's a bit of a contrivance at the moment, but we're going to leave that in for now. And we've got our first, our second and our result, and we're going to actually define the first and second as 3 and 4, and our result's going to be our first plus our second. So we have our program here, and really what we want to be able to do, if I press clear on this, we want to be able to press the compile button. Now whenever we press the compile button, we want to create the actual assembly language code that will allow us to run this program on our CPU. So as I said, at the moment this is a little bit contrived because it's just a very simple bit of programming, and it's not as if it's a full compiler. We're going to get into more details in compilers later on in the course, but this is just to give you a roadmap or a direction from a high level language down to actually running the high level language on our machine. So what would happen is whenever we open up the main here, the main is going to give us our start address. So this is our directive that tells it the start address for our variables. And we're going to actually also what that would do, it would actually go in and it would save the existing values on the registers to somewhere in memory. Now usually it would save it to something called a stack, but we've not gone into the stack yet, and we will go into it later. So it would save the values for, say, the 4 registers R0, 1, 2 and 3. It would save them in memory somewhere. Now we would be able to go in and we'd be able to actually run through the code, and at the very end it would save the result into memory, and then it would go back to the stack or somewhere in memory, and it would pull back out the original values for R0, 1, 2 and 3. So in effect we don't want to overwrite what was already in the registers R0 to R3. So that's what the main section would do. Now whenever we come in here to the dimension, so our dimension again is as an integer, and we've got first, second and third. So it sets aside memory locations first, second and third, and we've seen that it sets them aside here because what we do is we define first, second and third, and the first is the first memory location at the start address, and then this becomes the next one and then the next one. So that's going to be in memory location 30, 31 and 32. And then finally we work out the actual result, and the result is first plus second. So this part here, we want to be able to actually write the whole of the assembly code here, right, that our machine will actually understand. So again, it's a bit contrived, but that doesn't matter. It's not as if it's a full compiler or nothing like it. It's just a little bit of fun at the moment, just to show us that we can go from a high level language down through a compiler. Now once we went through the compiler, what we could do is we could do Control C. For the moment we can do this, Control C, and we can go back into the debugger and we can go Control V. Now what we can do is we can go through our pass 1. So our pass 1 is going to define all the label positions if there were any jumps. Now in this instance here it's a simple code, there's not any jump commands, but it's going to define any possible jumps, and it's also going to set aside the actual memory for each of these variables here as well. So we press the pass 1 and again we get our actual assembly language code that will actually run on the machine, and our pass 2 will give us the actual machine code. So once we've done that, we can press the debug and work through our debugger, and we're going to have our 4 plus 3 will give us the value of 7. So once we've done that, you can see that it's actually set aside the answers here. So we've got a 3 plus 4 and it puts 7 in this location. So when we've finished up, we're going to have a value of 3 in memory location 31, a value of 4, sorry, a memory location 30, a value of 4 in 31, and our answer will be in memory location 32. So we can go in and we can export that. So we click the export and we find our path that we want to actually export it to. So my file is in this folder here, so it's the mysim file, so it's going to be in this folder. So Control C and Control V, OK in that. So that's us exported the program, and we'll go ahead now and we'll open it up and the CPU will actually run it. So that's us got our CPU open. So remember to reset the simulation up here and then click on the reset button here, and then we can right click, edit contents, and we can open up our file, which is mysim, close window. Now we're ready to run the simulation, so if you click on simulate and tick enable. Now we'll let this just run all the way through, so you can see it's loading up the program now, and if I drop in here you can see every single change here within the system. Okay, so that's it almost loaded. When it gets to FF, that's a little bit finished. So that's at FF, and you can see it's put in the value 3 and then the value 4. So that's it moving these values into memory. It then takes one of them out of memory, so it takes value 3 out, and then it'll add value 4 onto it to get an answer of 7. So you can stop the clock there, and that's it finished. It's got the answer 7 sitting in R0, and the end command here is the CF. So if we were to drop into the CPU and then actually drop into the memory, so I'll try and get this into a better form so you can see it a bit better. Okay, I'll leave it there. So if we begin to drop into the RAM, you can see the RAM elements here. So what we want to do is find 32. So that's the first 16, and then that works out for the next 16. So we're going to have our value of 3. So you can see the value of 3 sitting in memory location 30. A value of 4 sits in memory location 31. And our memory location 32, if I drag it over here and find that for you. So that's memory location 32, and it contains the answer 7. So that's us completed a full process of running through a high level language, compiling it, and then running through the first pass of an assembler to get the actual assembly language, and then passing through a second pass of the assembler to get the machine code. And then we've outputted it, well, we've actually tested it in our debugger to see it works, and when we see it works, we've outputted it to our file, loaded it into our CPU, ran it in the CPU, and we've seen the answer, and we've checked and found the memory locations that it saved the values to. So this is a full process that we've now worked through for the first time, And as I say, and I have said a few times here, it's a little bit contrived because obviously it's not a full compiler that we've written. It's just a little simplified version of something that will allow us to show the full process. So that's all for this section here. In the next section we're going to go on and we'll look at the floating point unit, seeing how we're going to design a 16-bit floating point unit that we can then use along with this in order to allow us to do a lot more interesting things. So thank you for listening. I'll get you on the next video. Goodbye.